Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Grade 8 learners, welcome to Term 4. My name is Patuchito Singo and welcome to today's Natural Sciences lesson. This lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the topic the solar system. The subtopic, which is our main area of focus, is the sun, objects around the sun, and its position in the solar system. Now, let's look at today's objectives. Now, by the end of today's lesson, you should be able to explain how the sun emits light and heat energy, describe the structure of the sun, relate the types of reactions that occur in the sun, state the 8 planets in our solar system, identify where these planets are in relation to the sun, and state that the Earth is the third planet from the sun. Give reasons why the Earth is the only planet that is known to support life. And all of this is sourced from your CAPS document on page 53. Now let's look at pre-knowledge. So this is what you have learned prior to today's lesson. It has basically laid down the foundation for today's lesson. In the 6th grade, we learned about the solar system and systems for looking into space, as well as systems to explore the moon and Mars. I'm just pulling up a picture here. I'm sure you remember seeing this picture when you were in the 6th grade. Okay, so next we're going to do a baseline activity. So I'm going to read out the questions and then give you time to answer these questions. Okay, so what is the first question? The first question is, which is the hottest part of the sun? And the second question reads, the sun's energy comes from gases being squeezed together until hydrogen turns into helium. Where do you think the gases are squeezed together the hardest? And then the third question is, what are the dark spots on the surface of the sun called? I'm going to give you 3 minutes to answer these questions. Then after 3 minutes, we will do the solutions together. Do not forget to send in your responses to the WhatsApp number, which is at the bottom of the screen. See you after 3 minutes. Welcome back, grade 8. I'm sure you've been busy working on the baseline activity. So now let's do the solutions together. The first question read, which is the hottest part of the sun? The hottest part of the sun is the core. What is the core? The core is the middle part. It is the middle part. And then the second question, the sun's energy comes from gases being squeezed together until hydrogen turns into helium. Where do you think the gases are squeezed together the hardest? They are squeezed together the hardest in the core, which is the middle part. And then what are the dark spots on the surface of the sun? What do we call these spots? We call them sunspots. I'm going to give you a minute to copy down the corrections. Welcome back. I'm sure you've copied down the corrections. Now let's move on to terminology. These are the very, very important terms that we're going to come across during today's lesson. So let's go on and look at the terms. The first term is sun. This is a medium-sized star which is the center of the solar system. And then star, what is the star? This is a body of hot glowing gases in space that produces energy. And then nuclear reaction, it is a type of reaction in which the nucleus of an atom changes its characteristics and becomes something else. And then solar system, this is the sun and planets, and the planets and the other objects that move around the sun. And then terrestrial planets, these are planets that have solid rocky surfaces. And then let's move on to slide number 2 of our terminology. Gas planets. These are planets that are mainly made of gas with small cores of rocky materials. And then a dwarf planet. This is a body-like planet, but does not a body like a planet, but that does not clear its orbital path. And then algae, these are non-flowering stemless water plants. And then evolution, this is a gradual development from a simple to a more complex form. Now, let's learn about the sun. Let's talk about the sun. So here I've drawn up a picture of the sun, the outside of the sun, what the outside of the sun looks like, and then the inside of the sun. As you can see, the different levels until you get to the inner core. Remember, we talked about the inner core when we're learning our baseline activity. So now we know that the sun produces heat and light, but how does it do it? Now let's learn. In the sun's core, 4 hydrogen nuclei. Remember when we're learning about atoms in term 2, and one of the elements we learned about was hydrogen. So the nuclei of hydrogen, which is 4 of them, are squeezed or fused to form a new helium nucleus. Remember, we also learned about the element helium when we're learning in term 2. And then this process where we are squeezing hydrogen nuclei to produce new helium, a new helium nucleus. This whole process is called nuclear fission. So these reactions are given the name nuclear reactions. So that is the name of those reactions. And they produce vast amounts of energy in the form of heat and light. So that's how the sun produces heat and light energy, by squeezing or by nuclear reactions that are bringing together hydrogen nuclei to produce helium. So this reaction produces a lot of energy in the form of light and heat. So heat and light from the sun travels in all directions in space. That's why we can also get some of that heat and light energy. So some of this heat and light energy eventually reaches the earth. Our planet is called the earth. That is the name of our planet. So some of this heat and light energy from the sun that is a result of a nuclear reaction does eventually reach the earth, making life possible on earth, life possible on our planet. I'm just going to pull up an illustration of what I mean by the fusion or the nuclear reaction. Okay, so we've got 1, 2, 3, 4 hydrogen nuclei. So they are squeezed or they are fused together to form a new helium nucleus. And in this process, we still have a byproduct. What is that byproduct? It is energy, and that energy is in the form of light energy. It is also in the form of heat energy. And once this reaction has occurred and light and heat energy has been formed, some of it reaches our planet. What is the name of our planet? The name of our planet is the Earth. It reaches our planet and then it makes life possible. Now, I've got another video just to further illustrate this nuclear reaction that I'm talking about. So we have 4 hydrogen nuclei. We fuse them together to produce a helium atom, and then the process releases energy. What kind of energy is it? Look at this picture here. It is heat energy and it is light energy. So that's how the sun produces heat and light. That is how the sun produces heat and light. That's how it is done. So now let's describe the sun. What is the sun like? So the sun is a star, a medium-sized star, and it is made up of hydrogen and helium and other gases. What are these other gases? A bit of carbon, a bit of nitrogen, and a bit of oxygen. So the sun energy spreads out into the solar system in the form of heat and light. That's how we get heat and light from the sun. So there is the picture of the sun producing heat and light energy to help sustain life on our planet. Now, that is the solar system and how the sun is positioned. This is the position of the sun, and we have planets. So now we're going to learn where our planet is. So the movement of the earth around the sun is called a revolution. So the earth moves around the sun. We have learned something new today. The earth moves around the sun, and that movement is called a revolution. So the movement takes 365 days to complete. So it's slowly moving that very long distance around the sun. Now, for example, today is the 11th of October 2022. So in the year 2022, today is the 11th of October. So which means it's day number 283 out of 365 days of the year, which means the earth has been moving or has been revolving, has been moving for 288 days. For 283 days. But that's not the only movement that the earth does. The earth also rotates on its axis. But how long does that rotation take? Each rotation takes 24 hours. So I'm going to pull up a picture here. So this is the sun. And this moving globe here is the earth. So as the earth is moving here, so this movement around the sun takes 365 days, which is equal to 1 year. 365 days, which is equal to 1 year. So it takes the earth 1 year to move or to revolve around the sun. But as the earth is revolving around the sun, there is also another rotation that is happening. The earth is also rotating on its axis. As you can see here, the earth is revolving around the sun, but it is also rotating. And that rotation takes 24 hours. What else do you know that takes 24 hours? A day. A day is 24 hours long. So it takes a day for the earth to rotate on its axis. So the earth is rotating. The earth is rotating on its axis as it revolves around the sun. Like I said, today is day 283 out of 365 days of the earth revolution around the sun. So I leave it up to you to calculate how many days the earth is left with to finish its revolution. So now let's move on to activity number 1. I'm going to read out the questions. When I read out the questions, I'm going to give you time to answer them. The first question reads, list gases that make up the sun. The second question is, describe the sun. The third question is, which two types of energy do we get from the sun? And then the fourth question is, how many hours does it take the earth to rotate on its axis? I'm going to give you 4 minutes to answer these questions, and then after 4 minutes, we will do the solutions together. Do not forget to send in your responses to the WhatsApp number at the bottom of the screen. And when you do send in your responses, please do mention the name of your school so that we can acknowledge it. See you after 4 minutes. Welcome back, learners. Now let's answer the questions together. List gases that make up the sun. List gases that make up the sun. The gases that make up the sun are hydrogen and helium. So we've got nuclear reactions between hydrogen atoms to produce what? Helium. And then describe the sun. Can you give us a description of the sun? The sun is a medium-sized star. It is a hot ball of glowing gas. It is a hot ball of glowing gas. And which two types of energy do we get from the sun? Do you remember them? We get the two types of energy we get from the sun are heat and light. The two types of energy we get from the sun are heat and light. And how many hours does it take the earth to rotate on its axis? How many hours does it take the earth to rotate on its axis? It takes 24 hours for the earth to rotate on its axis. It takes 24 hours. So I'm going to give you 2 minutes to copy down the corrections. Welcome back, grade 8. I'm sure you've had enough time to copy down the corrections. Now let us move on to the next slide, which is objects around the sun. Objects around the sun. So the sun and the objects in the region of space around it are called the solar system. They are known as the solar system. The sun is the largest object in our solar system. So the sun is found in the center or in the middle of the solar system. So the sun's massive size, remember we have said the sun is the largest object in our solar system. So its massive size and its large gravitational pull causes the planets and other objects of the solar system to orbit around it. So the sun's size and its gravitational pull causes all the other objects and all the other planets to orbit around the sun, to orbit around the sun. So now let's look at a picture of our solar system. So now we have the sun here in the middle. We said the sun is at the center of the solar system, and then we find other objects around the sun. We find other objects, and some of these objects are planets. Some of these objects are planets. We'll look at the planet. There's Mercury, Mars, Earth, Venus, Uranus, Jupiter, and Saturn, as well as Neptune. So this is what our solar system looks like. And the sun, as you can see, it is the largest object in our solar system. There are also other objects that we can find in the solar system. So all these objects Because of the sun's large size and its gravitational pull, they rotate around the sun, or they orbit around the sun because of those two facts. Now, let's talk more about the objects around the sun. So there are 8 planets that orbit the sun. There are 8 planets that orbit the sun. What are these planets? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are 8 planets that orbit the sun. So these planets are different sizes. They're not all the same size as you saw in the previous slide, in the illustration that I showed you. There are different sizes. And these planets at different sizes arranged in the solar system from the largest planet to the smallest planet. They rotate on their axis and revolve around the sun. Remember, we just learned that it takes 24 hours for the Earth to rotate on its axis, which is a day, and it takes 365 days for the Earth to revolve around the sun. So that is the rotation and revolution information about the Earth. So the other planets also do that. They also rotate on their axis and they also revolve around the sun. So now, to remember the planets, I know there are quite many. There is 8 of them, but it is easy to remember them. And guess what? This little mnemonic that I'm going to give you is going to help you remember the names of the planet as well as the order that they are in from the sun, the order that they are in from the sun. So let's go. My very earthly mother just served us noodles. So now, this is going to help you remember the M here. The M stands for Mercury. The V stands for Venus. The E stands for Earth. The second M stands for Mars. The J stands for Jupiter. The S stands for Saturn. The U stands for Uranus. And the letter N stands for Neptune. Let's do it again. Let's say it together this time around. My very earthly mother just served us noodles. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. MVEMJSUN. There are 8 planets that orbit the sun. There are 8 planets that orbit the sun. Now I've just pulled up an illustration of these 8 planets that orbit the sun. So this is the sun. That is the sun. And let's look at the 8 planets that orbit the sun. Let's look at the 8 planets that orbit the sun. We've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. My very earthly mother just served us noodles. So those are the 8 planets that orbit the sun in our solar system. So they also rotate on their axis and they do revolutions around the sun. Now, these planets, these 8 planets, they are divided into 2 groups. Now let's find out what these 2 groups are. So we have what are called the inner rocky planets. We have what are called the inner rocky planets and the outer gas giants, which have different properties. So the inner rocky planets have different properties from the outer gas giants. Now, let's talk about the inner rocky planets. Let's describe them. Let's describe the inner rocky planets. So the inner rocky planets are 4 in the solar system that are near the sun. So which means if we have 4 inner rocky planets, we also have 4 outer gas giants. Now, which ones are the inner rocky planets? The inner rocky planets are Mercury, Venus, Earth, and Mars. Those are the inner rocky planets. And all of these four, Mercury, Venus, Earth, and Mars, they are made of rock, and therefore they are called the terrestrial planets. They are called the terrestrial planets because of this rock that they are made up of. They are called terrestrial planets. Now let's talk about the outer gas giants. The outer gas giants, which is the remaining four. So there are four planets. There are four outer planets, the outer gas giants. What are they? They are Jupiter, Saturn, Uranus, and Neptune. Those are the four outer gas giants. So all four are known as the gas giants because they are made mostly of gas. Just so says the name, they are called gas giants. So it follows that they are made up of gas. So that's the reason why they are called the four gas giants. So Saturn and Jupiter consist mainly of helium and hydrogen, whereas Uranus and Neptune are made up of water, ammonia, and methane. As you can see, all these are gases. That's why we call them the gas giants. So there are the gas giants. We have Jupiter, Saturn, Uranus, and Neptune. So these are the four gas giants, the outer gas giants. Now, let's remind ourselves. We said these planets, the 8 planets that orbit around the sun, are different. They can be divided into 2 groups. We've got the terrestrial planets and we've got the gas giants. Do you remember which ones are the terrestrial planets? The terrestrial planets are Mercury, Venus, Earth, and Mars. And then the gas giants are Jupiter, Saturn, Uranus, and Neptune. So we divide them into 2 groups. Now let's compare the terrestrial planets and the gas giants. What are the differences between the two? I'm going to pull up a table here. So on the left column, we've got the terrestrial planets, and then on the right column, we've got the gas giants. So now let's learn about the differences between the two. Let's compare the two. So the terrestrial planets, which are the first 4 from the sun, they are close to the sun. Remember when we looked at that picture with the order of how the planets are arranged from the sun, and that little mnemonic that we did, my very earthly mother just served us noodles. So the terrestrial planets are closer to the sun, and then the gas giants are far from the sun. What other comparison is there? So the terrestrial planets have closely spaced orbits, and the gas giants have widely spaced orbits. Remember, to orbit is to go around, and then the terrestrial planets have small masses, and these ones are large masses. The terrestrial planets have a small radii. Radii, remember from your mathematics or radius, and then the gas giants have a large radii. The terrestrial planets are mainly rocky. They are mainly rocky. That's why they have that name, terrestrial planets, because of the rocks that make them up. And then the gas giants are mainly gaseous. And then the terrestrial planets have a solid surface. And then the gas giants have a gaseous surface. The terrestrial planets have a high density, whereas the gas giants have a low density because of the solid and gas surface. That's where the density is coming from. And then the terrestrial planets have a slower rotation, whereas the gas giants' rotation is faster. The terrestrial planets have fewer moons, whereas the gas giants have many moons. Then the terrestrial planets don't have rings around them, whereas the gas giants have many rings around them. The terrestrial planets also have a thin atmosphere. It has a thin atmosphere, and then the gas giants have a thick atmosphere. And then in general, the terrestrial planets are warmer because of their proximity from the sun, whereas the gas giants are cold. So those are the comparison between the terrestrial planets and the gas giants, between the terrestrial planets and the gas giants. Now let's talk more about the objects around the sun. So what is the Earth's position in the solar system? So the Earth is the third, it is number 3. It is the third planet from the sun. It is between Venus and Mars. It lies between Venus and Mars. It is number 3 from the sun. So the Earth is believed to be the only planet to support life. Why is it so? It's because of the conditions that we have that are necessary to support life. So what are these conditions? These conditions are sunlight for plants to grow. Remember, sunlight is very important for plant processes. We also have oxygen in our atmosphere and oceans. We have oxygen in our atmosphere and we also have oxygens in the ocean. And this oxygen is very important to support life. Thirdly, the temperature must be moderate to keep water in liquid form. So our temperature and the oxygen that we have in our atmosphere and our ocean, as well as the sunlight, these are the conditions that are believed to be necessary to support life. So that's why it is believed that the Earth is the only planet that supports life. Now, let's talk about the temperature. We spoke briefly about the temperature that is conducive to keep the water in a liquid form so that you and I and the animals and the plants can take it up. So the Earth's distance from the sun, it actually provides the ideal temperature of 15 degrees Celsius range. It's a range to support life. We need a little bit of warmth to support life. So the Earth is the perfect distance away from the sun in order to allow life on Earth. So the average distance between the sun and the earth is called the astronomical unit, or AU, and it is equivalent to 150 million kilometers. That's how far we are from the sun. But do you ever feel how hot it gets in the summer? So that's how far we are from the sun. So this is the sun. Where are we? This is us. So this distance between the sun and us is 150 million kilometers. That's how far we are from the sun. So now we've reached our second activity. I'm going to read out the questions and then give you time to write down your responses and then send them through to the number at the bottom of the screen. So the first question is, identify the planets in our solar system. The second question is, name the planet that is closest to the sun. And number 3 is, state the most visible planet. And number 4, tabulate 3 differences between terrestrial planets and gaseous planets. I'm going to give you 5 minutes to answer these questions. Then after 5 minutes, we will do the solutions together. Welcome back, grade 8. Now let's do the solutions together. Identify the 8 planets in our solar system. What are they? Identify the 8 planets. This is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those are the 8 planets in our solar system. And then name the planet that is closest to the sun. So from these 8 planets, which one is closest to the sun? It is Mercury. So Mercury is the closest planet to the sun. And then state the most visible planet. The most visible planet is Venus. The most visible planet is Venus. And number 4, tabulate the differences between terrestrial planets and gaseous planets. So the table is on the next slide. So I'm going to give you 2 minutes to copy down the corrections for the first 3 questions, and then we will move on to the solution for question number 4. I'm going to give you 2 minutes to quickly copy down the corrections for the first 3 questions. Welcome back, grade 8. Now we're going to do number 4. Tabulate 3 differences between terrestrial planets and gaseous planets. So I'm going to pull up a table. So you're supposed to write down any three from this table here to tabulate. To tabulate means to to draw a table. It means to draw a table. So I'm going to give you 2 minutes to quickly copy down these differences between terrestrial planets and the gas giant. Welcome back, grade 8. I'm sure you had more than enough time to copy down the corrections. Now, what did we learn today? Let us summarize our lesson. Let's summarize our lesson. Today, we learned that the sun is a medium-sized star. And like other stars, the sun produces large amounts of light and heat continuously. That's why it keeps us warm, and during the day we can see the daylight. And then the energy from the sun, it comes from powerful nuclear reactions during which hydrogen gas changes into helium gas. So that nuclear reaction produces high amounts of light and heat energy. That's why we can feel the warmth of the sun and we can be able to experience the light of the sun, even though we are 150 million kilometers away from the sun, because of these very powerful nuclear reactions that are happening in the sun. What else did we learn today? We learned about the variety of objects that are around the sun. So the variety of objects that are around the sun include 8 planets and their moons and dwarf planets. So those are the objects that we find around the sun. And all the objects in the solar system have their own special features. So we call this all the solar system, and the sun is found in the center. It is found in the center. It is found in the middle of the solar system. And all these other objects, they orbit around the sun. They orbit around the sun and they have their own special features. So the solar system, what does it look like when you think of it? It looks like a flat disk, and the sun is at the center of that flat disk. It is at the center of the solar system, and all the other objects, they orbit around the sun in the same direction, which includes the 8 planets. Their moons, and other dwarf planets. So do you remember the names of the 8 planets? We've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So those are the 8 planets that orbit around the sun, together with other dwarf planets. Now, the gravity keeps all the objects in the solar system in their stable orbits around the sun. That's why we're not going to fall off, because the energy that comes from the sun and its great gravitational pull, it keeps us on all the other objects. It keeps the Earth and the other planets and the dwarf planets and all their moons. It keeps them orbiting and stable around the sun. That very powerful energy and gravitational pull of the sun. And then what else did we learn? We also learned about the Earth's position in the solar system. So where do we find the Earth? The Earth is the 3rd planet from the sun. It is number 3. Number 1 is Mercury, followed by Venus. Then we've got the Earth. Then after that, we've got Jupiter. And then we have Saturn, and then Uranus and Neptune. The Earth is the only planet that is known to support life. This is because of the following characteristics. The Earth's distance from the sun provides the ideal temperature range. Of about 15 degrees Celsius, and it makes sure that the water is a liquid, gas, or solid. So water can be found in 3 states on Earth: as a gas, as a solid, and as a liquid, on the Earth's temperature range, on this very conducive temperature range. And then sunlight provides energy for the food chain. The sunlight provides the energy for the food chain, and then oxygen is, which is a very important gas, is also available for life processes in both the land and oceans, and then early life forms and algae, they produced enough oxygen for the evolution of more sophisticated life forms such as ourselves. Now, I've been seeing WhatsApp messages from the different schools. Thank you so much for participating, and I hope to see you again. Now, here is our homework activity. I'm going to give you 2 minutes to quickly copy down the questions so that you can do them at home. Welcome back. I'm sure you've had enough time to copy down the homework activity. So in our next lesson, we're going to be learning about the Milky Way galaxy. Reminder, at the end of this lesson, do not forget to click on this tab which says complete and continue. Don't forget to click on that tab. And then until next time, please see you there. Bye-bye.